Welcome to the next video in Chapter 6 on polynomials. We're in Section 6.5, and the title of it is Solving Polynomial Equations. But in order to understand how to solve polynomial equations, we need to actually talk a little bit more about factoring. Yes, our friend factoring is returning. I know when we talked about quadratic equations, there was a multitude of different ways to solve quadratic equations. Higher degree equations, some of those methods are going to come back. The biggest one, though, the factoring method that we started talking with quadratics about, where you set factors equal to 0, that's going to be the major method here. But I have to show you some tricks and some techniques to factor polynomials of higher degrees. There's 3 that your book shows you in this section, so this video is just going to be talking about the factoring component, and then in subsequent lessons and videos, we'll put that together and use these factors to physically solve the equation. Okay? So first trick is the sum and difference of perfect cubes. Okay, and there's 2 patterns to look at here. The first one, if you have 2 perfect cubes being added together, a cubed plus b cubed, then what you get is the following. You get 2 terms, a binomial and a trinomial. The binomial follows the pattern a plus b, and the trinomial follows the pattern a squared minus ab plus b squared. Now when we take the difference of 2 perfect cubes, we also will get a binomial and a trinomial. These are slightly different, however. Their only difference will be in sign. So we start with a and b, but this time it's a minus b. Then our binomial, or our trinomial, excuse me, will also have the same 3 terms as before, a squared, ab, and b squared. But notice how there's now a plus sign in our first sign. So look at really all that's different. I'm going to just highlight a couple things here. The only thing that differs is the signs for these 2 patterns. Here's the way I always remember it. I memorize it. The pattern for the signs is same, opposite, plus. Here's what I mean by that. Once you get the 5 terms, used to the 5 terms of the pattern, and by the 5 terms I mean a, b, a squared, ab, and b squared, which unfortunately the best way to keep those down is to memorize them. Then to figure out where the signs go, I use this trick. Same, as in the same sign as the original. See how in the first term it's a plus, because in the first pattern it's a cubed plus b cubed. Then I use the opposite for my second sign, so in the sum I used minus, because that's the opposite. And then the third sign is always plus, so whether it's a sum or a difference, I'm always using a plus sign. So hopefully that will help. Plus we're going to do a couple examples shortly, but we'll involve some numbers so you can see exactly how this works. So here's our first example. We're going to do x cubed minus 8. We're going to factor that. Okay? So let's think about what our a and what our b are. Now notice x cubed is a perfect cube, and 8 is also a perfect cube. So that's our a cubed and our b cubed. A is going to be x, because the cube root of x cubed is x. B will be the cube root of 8, which is 2. So now we're going to use our pattern, and I'm rewriting it here first to start out. A minus b times a squared plus ab plus b squared. And we'll plug in x for a and 2 for b. So our first factor is x minus 2. Our second factor will be a squared, which is now x squared, plus ab, which is 2x, and then b squared, which is 4, plus 4. So that is how we factor x cubed plus 8. Try another example. Okay? Now we'll do a difference. X cubed plus 27, a sum. X cubed plus 27. Okay? X cubed is a perfect cube, naturally. 27 is also a perfect cube. It is, well, the cube root of 7, 27, is 3. So in the second example, we're going to use a to be x, and b will be 3. So we have x plus 3, because remember our first factor, we use the same sign as the original problem, so it's an x plus 3 this time. Then we do x squared, and then ab will be 3x, but we'll put a minus, because we always use the opposite sign from the problem, here. And then we do b squared, which is 9, so plus 9. Okay? Hopefully now you're starting to get the hang of it. Let's do one more that's a little bit more complicated. 27x cubed plus 64. Alright, are these both perfect cubes? Yes. A is now going to be 3x, because we have to see what cubed gets us 27, and also what cubed gets us x cubed, so it's 3x. And then the cube root of 64 is 4. So we'll use our pattern. We'll use 3x for A and 4 for B. So here we go. We get 3x plus 4 first, A plus B. Then we have to do A squared, which is 9x squared. Remember, you have to square both the 3 and the x. Then we do AB, that's 12x, so plus 12x. Actually, that should be minus 12x. Plus 16. One thing I forgot to notice, and I forgot to mention to you about this, and you want to take note of, that second term is a trinomial. And I know we've done a lot of practice with trinomials and factoring them, so you may ask yourself, hey, is this factorable? The answer is no. The trinomial is always prime.